record. Right. So let me just say that again. So we had our change in momentum, right? Which is our impulse. Impulse is change in momentum. And we say that this can happen very quickly, therefore it can be used to study collisions and explosions. Now we went down here and if we look back on the experiment, we saw that the smaller object, which was our Lamborghini, right, our smaller, slower object, right, was before the momentum, it was at 0.5, and then after the momentum, it was at 1. So that means that there was an increase in momentum, the momentum increased. And for our Corolla, our bigger and faster and stronger car, we saw that the momentum decreased. So we wondered why. We said, why, as scientists, we must ask the question, why is that so? Why does one increase and one increase? And that brings us to the law of conservation of momentum, right? When we want to conserve something, we want to keep it. We want to keep it the same way, right? For example, we have a pipe and there's a leakage. In order for us to conserve the water in that pipe, we must cover it so that it remains the same. So conservation, whenever we see conservation, we should think about being constant, not changing, right? Remaining the same way. And that can bring us now to applying this into real life, right? That can bring us now to applying this into real life. And we say conservation, as we said, constant, right? Anytime we say conservation, think about constant. So whenever two or more objects collide, right, their total momentum, so the momentum of the entire thing, both momentums will remain the same, right? Both momentums will remain constant, provided that no force is acting on them. No external force, no force of friction, no force of no other force, right? Or no other object or so forth.
So how
Um,
would
Go again.
one of them increase?
So one will increase, right? But one will decrease. You're not really required to know the reasons why, right? You're not really required to know the reasons why, but
You just
we can do a test on it quickly, right? Let's do a test on it quickly again. So we'll go back just to ensure that we're all on the same page. Just to ensure we're all on the same page. So you're not really required to know why. You're just required to know that the momentum is conserved for all um for all the objects involved, right? If we put let's restart where we were, and we have our velocity in this direction. Now we have our velocity back at 0.5 for ball one, and we have a velocity for ball two, which is our Corolla, at say 1. Let's put this at 1. So let's put that 0.5. 0.5. So let's just say our Corolla is just cruising and our Lambo is coming really fast, right? Our Lambo is coming extremely. I don't know. Let's not do that either. Let's make the that's for now. Let's make them be at the same velocity so that there's no confusion. Approximately the same velocity, right?
okay,
Yeah. So let's say you have them at the same velocity. Now, what does this? Let's just move forward, move on. What does this negative mean again?
Deceleration.
Not really.
deceleration.
Not really. Yes, it's not really deceleration. It means that it's going in the opposite direction.
In this case,
Yeah. In this particular case, we have x. We have our value. we have this ball moving in this direction, and then we have two moving in the opposite direction, which is negative. That's why we put it as negative. All right, but let's try it now. So we have our velocity at zero, at one, approximately one. All right, and let me try to put it at one. Just we have it at 0 point. Let's have it at one, and we have this at one also at negative one. So it's the same velocity, and they're moving in opposite directions. All right, I'm gonna take out this, so everything is good. Now, take note. We have the momentum for one at 0.5, and we have the momentum for two at 1.5. Now, add these two momentums, 0.5 and 1.5. What do we get?
1, sir. No.
Yeah, you're correct.
Correct? Oh.
You're correct, because the
What?
negative,
Oh.
we have negative one.
Oh.
Yeah, so it'll be negative one. Now let's look on so let me just write that down, negative one before the collision. They're moving in opposite directions. That's why we have a negative here, right? Now let's see what happens. Right.
Negative
So,
one.
what do we have here? What's the momentum?
0.1.
Mm.
0.001.
I say 0.
0.
Zero, sir.
What is the momentum for one? Look at the momentum.
0.9.
0.999.
You can't run it.
One.
In a run, yeah. You can't run it, sir.
Let's not round it off yet. So we have 0.999, right?
Yeah.
Yes, sir.
But what is the momentum for two?
0.
Zero.
0.001. Now add these two.
1.
1, sir.
Sir.
So it
Negative.
doesn't change. Negative one is the same.
But ito ada man negative, sir. So it still
Yeah.
come out as negative one.
Still come up as negative one.
Sir, equality Rodney for physics class.
Yes. Sorry about that.
Negative and
got-
negative. No
Yeah.
positive.
So negative plus negative.
Positive.
No.
In this case,
Times
negative same way.
Negative times negative is positive. Alright?
You know.
Yes, sir.
So if we add two negatives, negative, if we have negative 999 plus, try it in a calculator. 0.999 plus 0.001, negative 0.001, what we get?
Sir, no one.
Yeah, we still get negative one. So it's the same thing. Remember, our initial momentum was at negative one, right?
Yes, sir.
And our final momentum is now at negative one. All right, it doesn't change. All right, we're good.
Yes,
Are we okay?
sir.
Yes, sir.
All right, good. We'll go back now. So you're not really required to explain why this happens. You should just be able to identify that that's the case. The momentum doesn't change after a collision. It stays the same, right? So we have our first mass here. This, don't worry about this. This is not hard. This is, let's just say object A is our Lambo, and object B is our Corolla. That's how it's spelled, I think. So object A, mass 1 is object A, and mass 2 is object B. Right? Object B. Now,
Yes, sir.
what does this mean? What does this little tilde mean? What does that mean?
Inertia.
What, sir?
The little tilde. This right here. Right?
After. Oh.
Yeah. So it means that
So, what?
Leave it. I want to come at that.
V, you. I'm behind you.
V. In this case, it's V.
Apostrophe.
Yeah. So in this case, it's V because the object should be moving. The object would be moving, right?
Yes, sir.
Okay, so we covered a lot today, right? We covered a whole heap of content.
Chosen.
Alright, we covered a lot of content today. So we have this meanings after, right? Whenever I see this apostrophe here, it means the velocity after, right? But the mass remains the same. Mass m, right? It remains the same. But this means a after, right? That tilde up there, and then this means b after. That tilde up there. All right. As I said,
All right, sir.
this means after or final momentum or final velocity. We covered a lot. We covered a lot today. Let's do a question before we go.
All right, sir.
Let's do a simple question before we go, right?
Yes, sir.
All right. So Charlie A, we're doing this together, right? You're going to help me. So Charlie A, it has a mass of 300 grams. So Charlie A has a mass of 300 grams and a velocity of 9 meters per second. So Charlie A is our Lambo, right? Lambo. Charlie A. And Charlie B is our Corolla. I don't know if it's a Corolla, that's so bad. Right? Collides with a stationary trolley. So the Corolla is not moving, and both trolleys move together. All right, let's skip this question for now. All right, let's take it on. Let's see what's happening. I don't know why I didn't have another question. Don't know why I didn't put another question. So yeah, so we have M1 V1 plus M2 V2 equal M1
Then
V1. What goes up here?
after.
It go 1
Yeah,
Yeah,
so that is after
plus
M2
After
V2.
T2.
Right.
It go.
Yeah.
Yeah.
So we need to calculate now the momentum of trolley A before the collision. So we're not using these formulas yet, right? I just want to
33
ensure that we remember that. All right. So we have somebody who got that already. Let's work it with the class. So we have momentum equal mv, mass times
Velocity.
velocity. Now the mass is 3. So what would you do with this 3, right? Can we use this 300 grams right here? What we have to do? Remember?
Convert it.
Convert it to kg, sir.
Yeah. So 300 grams.
3,000.
No.
No?
3. 3K. 3K.
No. 1 kilogram.
30.
No.
Oh, 0.3, sir.
0.3. Right. That's what's worked with. So 1 kilogram is equal to 1,000 grams. Right. If we
Yes, sir.
have 300 grams, what would they do here? We would cross multiply, right?
Yes, sir.
Cross multiply. So we will have, help me out now. What do you have? X times
1,000.
1,000 grams.
so 1,000 x equal 300 times
1
So,
kilogram.
300.
1 kg.
So now we want to find x. How would you go about finding x now?
multiply them.
So
What do we want to get rid of?
Zero them.
1,000. 1,000, sir.
So how would you do that now?
Carry over 300. No. Carry over.
What are we carrying
Over
over?
1,000, sir.
How would
1,000.
you, how would you do that now? How would you carry over the 1,000?
Carry over to the left.
No, sir.
No, right.
Divide.
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 So we divide both sides by
1,000.
1,000. right? So these two cancels, right?
Yes, sir.
Yes, sir.
And now we're left with, so 300 divided by 1000,
0.3, sir.
0.3 kilograms. Right, so we now have 0.3 kilograms, right, times velocity. What is our velocity again?
9, sir.
9 ms.
9 meters per second, right?
Yes,
Now, our final thing, what is this now? What is our final answer for momentum for trolley A?
Hold on.
2.7.
2.7, right? Let me just double check that. That
Yes,
sounds correct though. Yeah, it sounds correct.
So like he ain't sure himself.
2.7, right?
Yes,
Class
sir.
is up. Class is up. We'll leave this for next class. All right. We'll leave this for next class. All the best, guys. Enjoy the rest of the day. We'll meet tomorrow. Quickly, tell me how did you see the activity that was posted?
Yes, sir.
Right. Are we able to do it?
Sir,
Try the UD na
you
yun.
can join now.
Go ahead.
Idein naman.
Yeah. So I gave you a graph. I plotted the graph. Right. I
Uh-huh.
gave you everything that you need because some persons are having problems getting graph paper. Right. So I plotted the graph for you. Right. And now you have to identify. Can we jump over it too quickly? You have a class now?
No, sir.
No.
All right. Give
Maths,
me 2
sir.
minutes. You have maths now?
Yes, sir.
Yes,
Alright.
sir.
All right then. I'll send a video in the video. I'll send a video in the group. Then. All right.
Alright,
sir.
sir.
All right. All
Yeah,
the
up
best.
top.
Guys.
Big up, sir.
All right. All the best.
All right, sir.